Welcome back to the deep dive. Today we're tackling a decision that really defines a lot behind the scenes: efficiency, cost, reliability. It's all about choosing between custom and standard components.
Right. And we're zeroing in on one particular part, the motor body section.
Exactly.
So for you listening, the mission today is really about clarity. We've looked at sources that show how choosing the right outer structure, custom made versus just grabbing one off the shelf, how that fundamentally changes everything.
Yeah, from like the energy efficiency down to the actual cost over the life of the product, especially in big areas like EVs or industrial automation. And the core tension here, what the sources really dig into, is balancing, let's say, uniformity with innovation.
That's the crux of it.
Yeah.
When does a standard fit actually save you money strategically? And when does not having that tailored precision end up costing you more in performance or even market share?
It's a tough spot for engineers, isn't it? Trying to optimize that bill of materials, but still hit some really ambitious performance goals.
Right. Definitely. Okay, so before we get into the pros and cons, let's just quickly define what we're actually talking about, these motor body sections.
Right. What are they?
Well, they're essentially these specially designed aluminum profiles. Housings, really. They form the outer shell, the structure of electric motors, actuators, that kind of machinery.
And they're not just simple boxes, are they? They do some heavy lifting.
Oh, absolutely. They have like 3 critical jobs. There's the mechanical support, obviously. Then thermal management, they're key for getting heat away from the inside.
Super important.
Yeah. And, of course, protecting all the sensitive stuff inside, like the stator and the rotor.
And that precision matters hugely, doesn't it, for how everything lines up inside?
Critically. If the housing tolerances are even slightly off, you start getting problems. More vibration, bearings wearing out faster, and the big one is messing with the air gap between the stator and rotor.
Ah, the air gap.
That tolerance is just paramount for magnetic efficiency, for getting the most torque out of the motor.
And how are these things usually met? You mentioned aluminum profiles.
Typically, yeah, aluminum extrusion. Aluminum is kind of the go-to material here. It's light but strong, doesn't corrode easily, and it's, well, easy to machine.
Makes sense for tough environments like inside a car or on a factory floor.
Exactly. It gives you that blend of structural toughness and good thermal performance that you need for, modern power systems.
Okay, got it. So let's break down the first option then. Standard motor body sections, the off-the-shelf choice.
Right. These are designed for that sort of universal fit idea, geared towards massive production runs, meeting common industry specs.
So what's the big draw? Why do people choose these?
Well, the sources really emphasize efficiency and economics here. The big advantages are pretty compelling, especially if you need to scale up fast. First off, cost.
Cheaper.
Significantly cheaper, component by component. The tooling costs are spread over millions of units,
Right.
So the per unit price is hard to beat.
And that must make supply chain managers happy too.
Oh, definitely. That's the second point. Availability. They're easy to get. Lots of suppliers, distributors all over the world. It builds a really resilient supply chain. Less risk of relying on just one source.
Okay, so cost, availability, what else?
Speed. Simple as that. You get them faster. Quicker delivery times are huge for just-in-time manufacturing. It cuts down project lead times, makes inventory simpler.
But there's always a but, isn't there? That uniformity, the thing that makes them cheap and fast, must have downsides.
It does. That's the trade-off. You have very limited design options. If your product needs a unique shape or specific mounting points or, integrated features, standard sections just aren't built for that.
So you might have to compromise.
Exactly. The engineering team might have to compromise on the fit. Maybe the thermal performance isn't quite optimal. It could lead to, lower performance than you wanted. Or maybe you end up needing costly add-ons.
Like having to stick a bigger heat sink on because the housing itself doesn't cool well enough.
Precisely. The sources actually mention cases where those initial savings on the standard part were completely wiped out by the cost of fixing the problems later, like adding that extra heat sink.
Okay. So standard is great if speed, cost, and scaling are top priority and your needs fit within that sort of common range.
That sums it up pretty well. If you need quick turnaround, best possible cost, easy scaling, and your machine fits standard dimensions without needing major structural tweaks or super specialized cooling, standard is often the smartest, most profitable way to go.
Right. But what if you do need more? What if standard just won't cut it? That brings us to the other side. Custom motor body sections.
The tailored solution.
Tailor-made, designed for maximum performance, specific vehicles, specialized uses.
Yeah, these are designed and made to exact specifications. They have to align perfectly with unique engineering needs or even aesthetic requirements. This is where precision and performance really trump that initial component cost.
So what justifies that extra investment? It sounds like it costs more and takes longer.
It does. But the advantages focus on, let's say, 3 key areas. First, you get an exact fit.
Okay.
And that translates directly into better, more predictable performance. Because they're engineered specifically for the dimensions, the thermal load of that specific system, they maximize efficiency and reliability over the motor's whole life. They kind of solve problems before they even start.
And the second advantage you mentioned must be flexibility, right?
Yeah.
Getting beyond just the standard boxy shape.
Exactly. Huge design flexibility. You can build in unique features or finishes you just can't get with standard options. Things like specific mounting brackets, maybe specialized channels for liquid cooling right in the housing wall.
Oh, interesting.
Or complex internal structures like webbing to dampen vibration, stuff that's just impossible with a standard profile.
And thinking about EVs again, weight is everything. If custom lets you shave off weight.
That's absolutely critical. Custom design lets you use tools like finite element analysis, FEA, to optimize exactly where the material needs to be.
So no extra metal where it's not needed for strength.
Precisely. Put metal only where integrity demands it. This freedom in geometry often leads to significant weight reduction compared to the necessarily uniform thickness of standard profiles. That makes custom way better for high-performance stuff where every single gram impacts the system's energy use.
Okay, the benefits sound compelling for specific applications, but let's face the reality check. The drawbacks. You said cost and time.
Yeah, they're significant. The initial cost is much higher, not just the production run itself, but the NRE, the non-recurring engineering costs.
NRE.
Yeah, the complex design work, all the prototyping, testing, and then the investment in the custom extrusion die itself. That's a big upfront cost.
And that investment means it takes longer to actually get the part.
Substantially longer, yes. Each custom section needs that individual design, prototype, test, produce cycle. It can add months to project timelines. You need serious long-term planning commitment.
And unlike the standard option where you have lots of suppliers,
Your supply chain gets riskier. That's the third drawback. You have limited vendor options. Not every aluminum extruder can handle or even wants to handle complex custom jobs. So you might end up relying on just one supplier, or maybe 2.
which increases your risk if they have problems down the line.
Exactly. Production issues, capacity constraints, it all has to be factored into your risk assessment. It's a major strategic consideration.
Okay, let's try and pull this together. We've got standard. Cheaper, faster, widely available, but limited. Custom. Precise fit, better performance, flexible design, but costs more, takes longer, fewer suppliers. This choice sounds really high stakes.
It is. Because it dictates more than just the component cost. It impacts the total cost of ownership, the TCO of the final product.
That's a really key distinction, isn't it? Shifting from just the part price to the lifetime cost.
Absolutely crucial. The sources really hammer this point home. Engineers need to calculate if, say, a 3% efficiency gain over 10 years outweighs a 30% higher initial part cost. That needs proper performance modeling.
So when should someone listening seriously consider pulling the trigger on custom, despite the cost and time? What are those specific triggers?
Well, custom becomes almost mandatory when you're dealing with really extreme performance needs, especially thermal management. If your motor runs really hot or needs very specific integrated cooling, like those liquid cooling ports built right in, standard profiles just won't cope.
And what about design? You mentioned aesthetics and integration.
Yeah, if you need the housing to fit perfectly with, say, a complex chassis geometry, or if you need special internal features for mounting sensors or something unique, customization gives you that freedom.
Makes sense.
Also, branding and aesthetics. If the motor is visible and part of the product's look and feel, you might go custom for unique shapes or finishes to stand out. And again, we can't forget weight reduction. In EVs, that translates so directly to range and battery life, it can justify a huge premium.
Okay, let's circle back to that risk point. Custom gives you performance, but maybe ties you to one vendor. Standard limits performance, but gives you a samer supply chain. How do companies manage that trade-off successfully?
Often they use a kind of hybrid strategy.
Yeah.
For some components, maybe high-volume parts like battery housings where cost is king and performance differences are marginal, they might use standard profiles. But for the core stuff, like the main propulsion motor, where efficiency directly impacts how good the vehicle is, there they invest in custom.
So segmenting the product based on risk and reward.
Exactly. It's about figuring out where the performance gain really, really matters most.
It sounds like you need some serious technical depth to make this call properly. You need to know precisely how much performance you're leaving on the table with a standard part.
That's the core calculation.
Hmm.
If a standard housing doesn't handle heat well, how much bigger does the whole assembly need to be to compensate? Does that extra bulk and weight then cancel out the initial cost saving?
Right.
Standard sections often force designers to kind of build around their limitations. You might end up with bulkier, heavier, less efficient assemblies overall. Custom sections, though, let the housing become an integrated part of the system design from the start, optimizing the whole package.
So understanding these decision points is really the key to better efficiency and maybe even lower costs in the long run.
Yes, even if that initial custom investment looks higher on paper, it's about that total cost of ownership thinking.
It really feels like the smart decision maker knows when to lean standard for scale and known needs and when to demand custom for that precision and boundary pushing performance. That's what separates a good product from a truly great one.
Absolutely. And the best manufacturers, they offer both options. But they really rely on your engineering team, the customer, to bring solid data, defining exactly where compromise is okay and where perfection is non-negotiable.
Okay, that brings us towards the end of our deep dive today. So, quick final summary. Standard is your path for speed, lower initial costs, and reliability when dealing with common requirements and scaling up.
Right. And custom means superior performance, that perfect fit, and really vital design integration, especially for demanding or unique projects where TCO and efficiency are the absolute main drivers. And if we think about the bigger picture, you know, custom sections enable unique designs, critical weight savings,
Yeah.
things that really differentiate products in the market.
Yeah.
It raises a kind of provocative question, I think. Given these significant advantages you get from tailored components,
Yeah.
how much actual next-generation innovation, how much product differentiation is maybe being held back globally, simply because engineers default to standard parts to keep those upfront costs down?
So, choosing standard for cost might actually be slowing down the pace of technological progress overall.
It's possible. That's the strategic trade-off, isn't it? Cost versus the potential for real leaps forward.
Yeah.
Something for everyone to think about.